Hello folks. Well, this time around I want to talk about command shells and about shell scripting. And since this term we're going to be doing a lot of work with bash scripting, this is going to be fairly significant stuff. But today we'll just get into sort of an intro and overview, and in the next couple of sessions we'll get into the nuts and bolts of bash. So let's see. The idea is that for most operating systems, the kind of set of commands that's actually built into the operating system are meant to control the operating system. They're fairly specialized, fairly intricate, fairly involved, and they're not really that well suited for direct interaction with whoever's using the system. So the idea is, for most systems, there are a variety of different interfaces that are provided to interact with the user, to take your commands and turn them into actions that the operating system is going to perform. So these can either be, graphical user interfaces where you're clicking on things and moving stuff around and using the mouse and tapping the screen and whatever else might be going on. Or they can be command-driven systems, like the ones that we typically use when we're SSHing and we're sitting there typing in commands and letting it go off and do something. So we usually refer to these as command shells, this kind of interpreter that's reading what you type or grabbing your actions, capturing your actions, and deciding what to do with them. So just as a quickie example here, if I'm sitting in my bash session here and I type in a command like ls, then that's actually going off to the shell, the command interpreter, to figure out what should be going on. Oh, I don't actually have anything interesting there. So it's figuring out what it needs to do, doing it, and letting me see the results. So it's interpreting my commands as we go. Now, there are a ton of different command interpreters out there, different shells. So there's one that's just the basic shell, just sh, bash, the born-again shell that we're going to be using. There's a tcsh, there's a zsh, there's a huge collection of different shells out there. Now, again, we're going to be using bash. You can actually change which shell you're using, so there's a command chsh for change shell that you can experiment with a bit if you want to, but again, for our purposes, we're going to keep coming back to bash. All right, let's see, and I think this is just exactly what I just said. Lots of different shells. We're going to be playing with bash. Now, quite often when we're working in our systems, there is some set of relatively complex actions that we have to perform multiple times. So if you've got a piece of software that you need to install someplace, you might be installing that over and over again on lots of different machines, or over the course of time you might need to reinstall it on your own machine. Or if you're configuring machines, or if you're carrying out backups, or if you're setting up test environments or development environments or production environments, or running test collections or generating reports, there might be all sorts of different sets of actions that you might need to carry out. If we do it manually, there might be 10, 20, 100 different commands in sequence that we type out in our little bash shell to get it to do what we want. Now, if we want to be able to do these things reliably, then probably what we're going to do is record them all somewhere and say, okay, go off and run this set of commands for me. So this is the idea of shell scripting, where we have a sequence of shell commands that we want to perform in some kind of an order. And again, the idea is we basically stick them in a file someplace. So we've got this complex set of commands, we need to do them in sequence, and there might be choices involved in them. Check if there's enough disk space. If there is, then do this. If there's not, then do something else instead. For lots of the commands, there might be arguments involved where we have to get a file name or a directory name from the user, or from another file, or from another program. So most languages that allow us to do shell scripting to write these collections of commands are full-on programming languages, right? So they've got loops and if statements and functions and all that kind of thing. They're just geared towards interacting with the user and to interacting with the operating system. So the whole idea is to try and help us automate the sorts of tasks that involve lots of different steps or complex sets of arguments. Again, makes it more efficient. Instead of having to type these commands in, instead of having to type my 100 commands in, I just run the script. It reduces the chance of errors, right? The chance of me accidentally missing a step or mistyping an argument. And so this is a fairly common thing that you're going to wind up having to do. So Bash is the shell script that we're using, and so that's the scripting language that we'll study in the next couple of weeks. So we can write these collections of commands in Bash, stick them in a file someplace, and tell the Bash interpreter to go through and run the commands that are in this file, in this script. Now again, these are going to be fairly highly text-based because they're based on all around this idea that it's commands that the user is typing, right? Or file names, or directory names, or paths, that kind of thing. So the nature of it means that you're going to see some syntax decisions and some language features that are a little different than you'll see in a more general purpose language like C++ or Java or whatever else it might be. So these are some of the things that I want you to have in the back of your mind. What we're going to do again is to create files that contain collection of Bash code that we want to run at different times. So to do that, again, we'll put all the commands in a file. Usually we'll give it an extension of .sh to indicate that it is actually a shell script. And we'll stick a line at the beginning that identifies which specific interpreter we want to use. So I'll show you an example of that in just 1 second. Once we've created this file of commands, then we're going to make it executable so that I can basically just run the file. So we're going to go back to that chmod command that we discussed earlier and make it executable. So if I've stuck it in a file named mystuff.sh, chmod user plus execute and mystuff.sh, and then we can simply run all the commands in the file by typing in our /mystuff.sh. So let's take a look at that in action just to kind of make this a little clearer, hopefully. So let's create a shell script that's not going to be anything too terribly exciting. My script.sh. And so the first thing we do is tell it which shell script we want to use to interpret the commands that are here. And you're going to find that you can do this with Perl or with Python or with all sorts of different scripting languages. But again, the one we're using for now is Bash. So we put that in as the very first line, saying, interpret this file using this interpreter. And then we can just stick in commands. So you can stick in any regular old Linux commands or Bash commands that you want. We'll get it to do an ls. We'll get it to say something. That was the content of this directory. Maybe we'll stick in another one. Bye. So you just stick in a bunch of commands, anything that you could have typed in at the command line, and we'll save it. And we can see that it's in there. If we take a look at it, again, you'll note that it's not executable yet. So if I try and run it right now, it's going to complain and yell at me. Right, it's not an executable script. So we'll make it executable. So that's this chmod user plus execute myscript.sh. And if we do our ls-l myscript.sh, now we can see that it is executable. And so we'll try running it. myscript.sh. And there we go. It ran those 3 commands. It ran the ls, it ran the 2 echo statements, and then it ended. And that's the idea of our shell scripting. I mean, that's about as simple a shell script as you can come up with, but that is the basic notion. So what we're going to do over the next week or so, or maybe 2 weeks, is just more and more practice with the Bash scripting language and writing scripts to do useful things for us. All right, we will leave it there for now.